cheat sheet. Remember, the cheat sheet is something we just try to do at the end of every single topic. And that is, the purpose of a cheat sheet is you don't want to have, you're sitting down, it's an hour before the exam, you get to go in the room yet, so you still have your bag with you. And it's an hour before the exam, so obviously you want to do a last minute look over, right? But when you're doing that last minute look over, you can't be, tossing through the whole notebook. No, you don't want to do that. That last minute look over, you should have one page, and I call that page a cheat sheet. And that one page should have everything that you wish you could carry into the exam. Yeah. If you could take one page to cheat with, what would that page have on it? If you could carry one page to cheat with, you would have probably write small, because you would have probably want everything to fit on that one page. And so you can't carry the page in the exam to cheat with, but imagine you had that one page to look at right before the exam. And that one page have all the important information you need to know. So this is the cheat sheet for coordinate geometry, right? Remember, coordinate geometry had a couple of different steps, right? First, we had we had an equation, and you had to go from the equation to the graph. And we know that this is going to look like this because, and let me just write the equation properly, right? You had the equation y is equal to x plus 3. We had to go from the equation to the graph, right? And so in order to do that, you had to remember this is your y-axis, this is your x-axis. In order to do that, you find the 2 points and plot. Now that is something you can't write out a whole example. No, you're supposed to be able to know how to do that, right? What else could go on your cheat sheet? Remember that the general equation of a line is y is equal to mx plus c, where m is your gradient and c is the y-intercept, whatever. I think it is intercept. So m is the gradient and c is the y-intercept, and the word intersect would also be correct. In terms of what, and all of these things, we just put it in little boxes, little ideas, right? In terms of the gradient m, if m is positive, the graph is gonna be going like this. If m is negative, the graph is gonna be going like this. So all of these are little things that you could have on your cheat sheet, and imagine you're just looking at this right before the exam. Everything you need to know. We saw that for a horizontal line, you have a horizontal line here. This will be the line y is equal to 3. If this is 3 here, then this is the line y is equal to 3, and that is the equation of a horizontal line, right? Your x-axis here this x-axis is also the line y is equal to 0. Is a horizontal line. The equation of the x-axis is y is equal to 0. Yeah, and you had to know that, and you had to know why when it comes to vertical lines. All right. You have your x-axis and your y-axis, and the vertical line will be going like this. And this will be at the point x is equal to 5, for example. So the equation of this vertical line is the line x is equal to 5. So the equation of a vertical line is the line x is equal to something. And so you have this here. This is your y-axis. And the equation of the y-axis is x is equal to 0, because it's at the 0 point on the x line. Yeah, similarly here, this is at the 0 point on the y-axis. You have to know the difference. And if anybody doesn't understand anything on this cheat sheet, stop me one time and ask. I'll explain it. Now is the time for you to ask. Don't wait for you to reach in the exam, right? Now is the time. So we spoke about horizontal and vertical lines. We spoke about certain things like perpendicular lines. All right, let me talk about parallel lines first. Right? Parallel lines are when the gradient of the first line is equal to the gradient of the second line. So you could have a little example here. You could have two lines. Let me say this line here, and then you have this line here. Right? And this line could be the line y is equal to 2x plus 3, and this is the line y is equal to 2x minus 1, and you could just put the 2's in the same color, showing that the two of them are equal. All right, so when you have the same gradient, those lines are parallel. We spoke about perpendicular. And that is where the gradient of the first line multiply by the gradient of the second line will give you minus 1. So if you take the gradient of the first line, multiply it by the gradient of the second line, you will get minus 1, which is perpendicular. And then we could have a little diagram here, because remember, these the cheat sheet. The cheat sheet, you don't want to do too much reading. Little sketches are really, really good so that you can watch it and understand it one time, right? So this is the line, let me just say, this line here is the line y equals x minus 1. And then I could have this line here, which is the line y is equal to minus x. And you notice I have it cutting through the origin, so c is 0, right? Notice that the gradient of this one, m1, is minus 1, and m2, the gradient is 1. So if I take minus 1 multiply by 1, I will get minus 1. Once you get minus 1, when you multiply the two gradients, that means the lines are perpendicular. They love to ask the parallel and perpendicular questions, eh? So you can see that in coordinate geometry, we did a lot. Then we had the part, we had to take a line and the line have 2 points. The first point x1, y1, and the next point is x2, y2. And we had to take these 2 points and we had to go and get the equation y is equal to mx plus c. So the first step in coordinate geometry was we had the equation, we wanted to get the graph. Now you have the graph, you want to get the equation. So how are you going to get the equation? You have the 2 points. You're going to use the 2 points. What do you need? You need to get m and you need to get c. So remember, m will be equal to, you have your formula, y2 minus y1 all over x2 minus x. And to find c, we could use one of the points. Right? So let me use x1 and y1. Right? So therefore, you use the equation y1 is equal to m that you found using this equation into x1, and then you have your plus c. And so everything here, you have m, you have x1, you have y1, you could just find c. And then we talked about the length of a line given 2 points, x1, y1 and x2, y2. The length of a line L will be the square root of y2 minus y1 squared plus x2 minus x1 squared. Or did we have the x's first? I think the x's were first, but it really doesn't matter, because Pythagoras equation c squared is equal to a squared plus b squared. Addition is commutative, so it'll be the same thing if we had this. So it just came from Pythagoras equation. Just remember, this is just Pythagoras equation. And then the last thing that we talked about, and I'm not sure, am I leaving out anything? Because the last thing that we talked about was the midpoint. So the midpoint given 2 points, x1, y1 and x2, y2. The 2 points, their midpoint, which is big M, is x1 plus x2 over 2, and then y1 plus y2 over 2. I'm not sure if we're forgetting anything. Please let me know if you think we're forgetting anything. But this is your cheat sheet that covers the entire topic of coordinate geometry virtually. So we have some questions here that we have to get into. I think we have about 4 questions on this side. Oh, we have a question under here we had to get to as well. But we did have a question on this side from one of the earlier classes. This was the question here. The line y is equal to x plus 1 minus x plus 1. You have x minus 1 and you had minus x plus 3. I'm not even going to read the question yet, right? I know I could just look at the equations because we learned how to do this. We learned that you could just look at your equations and you can sketch what they will look like, right? On an x and y axis, right? So imagine the first one is x plus 1. Well, I know that that's going to be cutting at plus 1. And the gradient is positive, so it's going to be moving so. Right? So this gonna look like the line y is equal to x plus 1. So when I draw that line, I should expect to get something like this, right? And look, the other positive gradient line, y is equal to x minus 1. So that is that and that. You notice these two gradients here are the same. So because those gradients are the same, I could expect that they would be parallel. And so this is cutting at minus 1 on the y-axis. And it'll be parallel to that. So I'll try to see how best I could sketch a parallel line here. I could probably even put the parallel sign on it. And so this will be the line y is equal to x minus 1. Notice I didn't read the question yet. And I done work out what the two lines gonna look like. I done work out where they're gonna cut the y-axis, if they're parallel or not. Then I have this line y is equal to minus x plus 1. So that's a negative gradient. It's gonna be faced the other way. And it's gonna be cutting at plus 1. So it's probably gonna be facing this way. But I could see here that this line gonna be cutting both of them, right? Y is equal to minus x plus 1. Look at the gradient of this. This is minus 1. The gradient of this is 1. So minus 1 times 1 will give me minus 1. So I could tell that this line, just by looking at those gradients, this line is going to be, oh, why is it not drawing, man? Come on. This line is going to be perpendicular to the blue one. And the same thing, because this is minus 1 and this is 1. So that means it's also going to be perpendicular to the other one as well. And I don't know where it's going to cut here, because I see it cutting on the x-axis. That might not be true. This is just a sketch. We're going to see how true that is when we actually draw the thing, right? And same thing for this one. This one is minus x plus 3. So I'll see that I'll need to go up to plus 3 over here. And this gonna be coming so, and it also going to be perpendicular to both lines. So I should get a kind of square diamond shape. And I just end smaller in it. All right. I could done see how I need to draw my graph just from the sketch. It'll be nice if I had the minus 1 here, and I'll need to have up to 3 here. It'll be nice if I had some space on this side, so maybe I could have up to minus 1 on this side, but I'll definitely want to have most of my space here. Right? So I could see that. So already I'm gonna draw, I don't know how I'm gonna draw my axes. I'll probably have one axis here for my x. No, sorry, for the y. And then I could have, well, I want minus 1 there, right? So minus 1 here. I could probably have the other axis here. I hope that'll give me enough. All right, so we have the two axes there, and I hope you all could see it because I know the color a little light. All right, but this is the y-axis here and the x-axis here. All right, so I could see there that I have my minus 1, 0, 1, 2, 3. I need up to 3, 4, 5, 6, 7. And on this side I have minus 1, and on this side I have 1, 2, 3, 4, 5. All right, let me see if this thing big enough, right? So for this line, I need 2 points. The points are, let me just say, if I use x is 0. So if x is 0, then y will be 1. So that is 1 point. And what about if y is 0? If y is 0, x will be minus 1. Interesting. If y is 0, I had to throw the 1 across, and x will be minus 1. So I have my 2 points here. The first point is 0 on the x, 1 on the y. So that is my first point. And then 0 on the y minus 1 on the x. That is the second point there. So let me just draw a line through that. This is the line y is equal to x plus 1. So if you want to draw a line, you find 2 points on the line, right, by just choosing whatever the x value is. So I'll do it again. Let's draw this one. So this one here, right? So I want 2 points, right? So I'll choose again when x is 0. When x is 0, and I just choosing numbers out of a hat. You could choose anything, right? So I'll just choose when x is 0, y will be minus 1. And let me choose something else. Let me choose when x is 2. When x is 2, 2 minus 1, y will be 1. So I have my 2 points there. So I'll do that in green as well. Oh, I didn't label these points actually. This is 0, 1. And this is negative 1, 0. Now I have the other 2 points, 0 minus 1, that is down here, 0 minus 1. And then the other point is 2, 1, that is over here. Yep, they're looking like they're going to end up parallel. If you get them meeting, then you know you do it wrong. Something wrong. They're supposed to be parallel. So hopefully they should not meet when I join them. Right. Very good. So you can see that those 2 lines look very parallel. And this is the line y is equal to x minus 1. You can see it cutting as minus 1 there. Now to sketch these 2, and I just move in fast. No. When x is 0, y will be 1. When x is 2, minus 2 plus 1 is y will be minus 1. Yeah, I guess I could do that. When x is 2, y will be minus 1, because minus 2 plus 1 is minus 1. Let me know if I'm making any mistakes, because you know on a Saturday, I'll be a bit tired, right? So sometimes I just make mistakes too. All right, I'll draw this in red. So let me draw my points first. My 2 points is 0 on the x, 1 on the y. No, 0 on the x and 1 on the y is here. That's this point, 0, 1. All right, good. And then we have 2 on the x minus 1 on the y. So that is the point 2 minus 1 there. And let me join them now. Y is equal to minus x plus 1. And now let's just draw the next line, the last line here, and I'll just do it right here. When x is 0, y will be 3. And when x is 3, minus 3 plus 3, y will be 0. All right? And so you can see I have my 2 points here, 0 on the x, 3 on the y. That is this, 0, 3. And then we have 3 on the x, 0 on the y. So that is that 3, 0. And then we join those 2 like so. Make sure they connect with their points, and we can see that the 2 red lines are very parallel. This line is the line y is equal to minus x plus 3. So this is what all of this mess of graphs could look like. You wouldn't get, well, no, I would say you will not. You will not get a question like this for CSEC. So this question is a little bit tougher. All right, just a little bit tougher. Once you could do this question, you could handle any CSEC question. So now we go tackle the CSEC questions. But first, find 2 points on each line. Well, we did that. On a graph sheet, plot the points, draw the lines, label the points, lines, and axes. We did that. Are there any perpendicular lines? Show working to prove. Well, we kind of did that. We didn't show the working though, but we could see, let's call this L1. Let me call this L2. Let's call this L3. Let's call this L4. So we could see there that L1 is perpendicular to L3, right? How? Well, we could see L1 that'll be M1 multiplied the gradient of L1 multiplied by the gradient of M3 is -1. So we could see the gradient of L1 is 1 multiplied by the gradient of the line L3 as -1. So we get -1 there. And the same thing for L1 being perpendicular to L4 for the same reason. 1 times -1 is -1. Once you get -1 for the answer, then the lines are perpendicular. Are there any lines parallel? Show working to prove. Well, yes, L1 is parallel, and this is the sign for parallel. L1 is parallel to L2 because M1, the gradient of L1 is equal to M2, which is the gradient of L2. We could also say that L3 is parallel to L4 because the gradient of L3 is equal to the gradient of L4. What shape do the lines form on the graph? Well, we could see that they form somewhat of a square, or you could even say a diamond, but it is very much a square. As you can see, all of the sides are equal. We could even use the graph to, because the questions do like to ask you that. Use your graph to measure the to measure the vertices. So we can see one vertex here is 0, 1. The next vertex here is 2, 1. We have another vertex here which is 1, 2. And then we have this vertex that ended up being smack on the x-axis. So that is 1 on the x and 0 on the y. And just like the diagram. So you see how good our sketch turned out to be. Because the sketch had a point on that x-axis, but I couldn't be sure because it was just a sketch, right? But now it looked like our sketch was very, very, very accurate after all. We have 2 points here, P and Q are the endpoints of the line segment PQ. Well, duh, right? Determine the gradient of PQ. Well, okay. Well, I know P. Ooh. Let me just use a smaller thing. P is equal to what? 6, -1. And Q is equal to 2, 7. So let me call this x1, y1. Let me call this x2, y2. It doesn't matter which one you choose. You could have choose this to be x2, y2 if you want. You will get the same answer, right? So, and you could try it both ways if you want to do the experiment and see. So the gradient small m is y2 minus y1 all over x2 minus x1. So the gradient small m is y2 is 2, no, y2 is 7, use your brackets, minus y1 is -1. You see why I say use your brackets, right? All over x2 is 2, and let me know if I'm making any mistakes, minus x1, which is 6. Use your brackets. So I have 7 minus 1 is 7 plus 1. I have 2 minus 6 is minus 4. So I'll have 8 divided by minus 4. So we have minus 2 is the gradient of the line PQ. So the coordinates of the midpoint for real, boy. That's what they're going to do, my boy. All right. So the gradient of the line PQ is minus 2. They want the coordinates at the midpoint. All right, I'm going to use the same x1, y1, x2, y2. So big M is, all right, x1 plus x2 over 2. And then y1 plus y2 over 2. So that is equal to x1 is 6 plus 2 over 2. And y1 is minus 1 plus 7 over 2. And so we could see here 6, 7, 8, that is 8 over 2. And then 7 minus 1 is 6 over 2. So you get your midpoint, big M, to be 8 divided by 2 is 4 and 3. Yeah, thanks, Isaiah. You know, sometimes when you're teaching from 9 in the morning, your brain just kind of start to stick a little bit. Please do not leave until I take the roll, eh? Right? You have, so there's your midpoint. All right. The equation of the perpendicular. So that means the line PQ. And let me just draw a little sketch right here. All right. We have 6 on the X minus 1 on the Y. So that is 6 minus 1 there. That is P. All right, and we have 2 on the X and 7 on the Y. So that is somewhere up here. So that is about Q-ish day. So we could see this line coming. So and we could have expected that line to be looking like that, because the gradient is negative. So remember, M is negative 2, right? What we want is the equation of the perpendicular bisector. Bisector means cut in half, right? If you remember when we did constructions in geometry. Right? So bisector means cut in half. So remember, the midpoint is what cuts this line in half. What is the midpoint? 4, 3. So 4, 3, 4 on the X and 3 on the Y might work out to be somewhere here-ish, right? Which really looks midpoint-ish. That is 4, 3. So the perpendicular bisector is that line that will be perpendicular to PQ, but cutting it in half. So this line will be perpendicular to PQ. If it is perpendicular to PQ, that means that the gradient of this line, let me call it M2, will have to be a half. The gradient of this line will have to be a half, because if M1, the gradient of M1 is minus 2. So M1 is minus 2, the gradient of the first line, right? M1, in order for it to be perpendicular, M1 multiplied by M2 has to be equal to minus 1. So if this is minus 2 multiplied by what will give you minus 1? The only answer is a half, right? So in order for these lines to be perpendicular, that means that this gradient for this line needs to be a half. Right? I have the gradient of the line, and I have a point on the line. That midpoint, M, that is on the red line. So I have the gradient, let me call it M2 because it's the second line. The gradient is a half, right? That is the only way it could be perpendicular. And I have a point, which is the midpoint of the first line, and that point is 4, 3. So I could find my equation now. So it'll be y is equal to a half, which is the gradient, times x plus c. And now I could use this point inside of there to find c. So y, which is 3, I'm using this point here in place of x and y, is equal to a half of x, which is 4, plus c. So therefore, y, which is 3, is equal to a half of 4 is 2, right? Plus c. So that means that when I throw this 2 across, c is going to be 3 minus 2. So c is going to be 1. So therefore, the equation of L2, which is perpendicular to PQ, implies y is equal to a half x plus 1.
Yes, sir.
Right. They said the equation of the perpendicular bisector. That tells me two things. Bisector tells me that the line is passing through the midpoint. And then perpendicular tells me that it is perpendicular to the blue line. So you understand how I get that in the sketch, right?
Okay.
Right, nice. Now, it's just one rule that we had used here, and that is when two lines are perpendicular, when you multiply their gradients, you are supposed to get minus 1. Do you understand that?
I do.
Right. So you see how the first line, the blue line, the gradient of the blue line is minus 2, and? So if I multiply the gradient of the blue line and the red line, I'm supposed to get minus 1 because they're perpendicular, and?
Yes.
Right. So that is how I got the gradient of the red line to be a half. Because a half multiplied by minus 2 is the only thing that'll give me minus 1. So you understand that?
Yes, I do.
So you're cool with how we get the gradient of the red line?
I am.
Right. And remember how the equation of a line is y is equal to mx plus c, right? So if you have m, if you have a value for m, and you have a value for x, and you have a value for y, well, then you could find c, and?
Yes, sir.
Right. Well, look, we have a value for m, that is a half. And then look, we have a value for x and y from that midpoint. That midpoint is a point lying on the red line as well, and?
It is.
So we have a point on the red line. So that means we could use the x value and the y value for the red line, and?
Yes, sir.
So that is what I did here. I went and I substitute my m, I substitute my x, and I substitute my y, and now I could find c, and c ended up being 1. Understand it now?
I do. Thank you.
Right, so now you have y is equal to a half x plus 1. This is c, this is m, and this is your equation of the perpendicular bisector. The line passes through, you can see they love to bring these 2 points, you know. A line L passes through the points S and T. All right, so they're calling it the line L. It's really the line ST, but they're calling it the line L, right? They want the gradient of the line L. Well, I know M is equal to Y. Ugh, come on, what's wrong with this? Sorry. I know M is equal to y2 minus y1 over x2 minus x1, and I have 2 points, so I could find the gradient, right? The equation of the line. But once I have the gradient m, I could use any one of these points to get an x and a y value, and I'll be able to find what C is. So I could find that. The midpoint of the line segment TS, well, I had a, you see how they like to use this line? The length, oh good, they're asking a length away. Look, they're asking for the length here, yes? All right, this is just an application of formulas. So I hope that earlier get a question like this for earlier exam, right? Is equal to y2 minus y1 all over x2 minus x1. Right? Let me call this x1 y1, and I'll call this x2 y2. You could do it the other way around. It would have been no problem. You would have get the same answer. Right? So now m is equal to y2. Use your brackets. y2 is minus 2 in brackets. y2 minus y1 all over x2, which is 0, minus x1. So now m is equal to minus 2 minus 6 all over, well, 0 minus 6 is minus 6. Please, guys, even I could make a mistake. So please keep your eyes peeled. Let me know if I am making any mistakes. We know that this will be negative 8. If the signs are the same, you add them and you keep the sign, over negative 6. Well, the negatives are gone. 2 into 8 is 4, 2 into 6 is 3. So 4 over 3, positive 4 over 3 is the gradient of this line. The equation of the line L. So the equation of the line implies y is equal to mx plus c. Right? So I have m. M is 4 over 3. For x and for y, I will use one of these points, and let me use this point here, because I could see that the 6 as the x will go into the 3. So I will use 6 as the x, and of course you have 6 as y as well, and now we could solve for c. So that means that 6 is equal to this 3. 3 into 3, 1. 3 into 6 is 2. So 4 2s are 8 plus c. And I throw across the 8. So c will be the 6 minus 8, which is minus 2. So therefore, the equation is y is equal to 4 over 3x minus 2. That is the equation of the line L. Now we want the midpoint. So I'll do the midpoint here, and I'll do the length here. So number 3. The midpoint M is just a formula x1 plus x2 over 2, comma, y1 plus y2 over 2. So that is x1. Well, let me just use the same x1 and y1 and thing here. So x1 is 6 plus 0, x2, all over 2, comma, y1 is 6 plus y2 is minus 2, all over 2. So what we will have is 6 over 2, comma, 6 minus 2 is 4. So 4 over 2. So that'll give us 3, and 2 is the midpoint of that line segment. So the midpoint, you notice, is big M, and the gradient is small m. Now the length of the line segment, so the length L, is equal to the square root. And let me just see something. Okay, so it is the square root of x2 minus x1 squared plus y2 minus y1 squared, and it is the square root of all of that. This is just Pythagoras theorem, right? Let me write it over a little better than that. Oh gosh, let me put in a little effort. Yeah, L is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. The square root of all of that. So that is the square root of x2 is 0 minus x1 is 6, and that'll be squared, plus y2 is minus 2, notice the brackets, minus y1 is 6, and that will be squared, and that is the square root of all of that. Right? So that means that we want the square root of negative 6 squared plus negative 8 squared. So that means we want the square root of 6 6s are 36, and the negative will be gone, plus 8 8s are 64. That means we want the square root of 100. And that means that, because 36 and 64 is 100, and that means that the square root of 100 is 10. And, well, you could just put units. So you could see what are the things they'll ask you. Most likely, they're going to ask you to find a gradient. They're going to ask you to find the equation of the line given the gradient or given 2 points. They might ask you for a midpoint. They might ask you for the length of the line. They love to ask you things that will require you to use this perpendicular business. Yeah, they love that. So let me see in this question here. Let me just make this stuff a little small so I don't crowd out the next question. JK has an equation like this. Determine the gradient of JK. Now the thing is, you know that if a line is in the form y is equal to mx plus c, then you just read off the number in front of x, and that is the gradient. So a person who is not aware will go and say, hey, look at how a 5 in front of the x, so the gradient is 5. But that would be wrong, because this line is not in the form y is equal to mx plus c. This line is in the form 2y is equal to 5x plus 6. So I had to get rid of that 2. I'll throw the 2 across. So now I'll have y is equal to, is I multiply by 2 on this side. So on this side, it will become a divide by 2, right? That means that y is equal to, when you have two numbers divided by the same denominator, that means you could split them up. 5x on 2 plus 6 on 2. So the actual equation of this line is not this. Right? I mean, yeah, that is the equation of the line, but it is not in the form of the general equation. So y is equal to 5 on 2x plus 6 divided by 2 is 3. This is the actual general equation of the line, where the gradient of the line JK is 5 on 2. You'll kind of be showing the examiner that you're an amateur. Yeah? And I'll tell you why. Generally, we prefer fractions. We even prefer improper fractions rather than mixed numbers. Because I could have said that that is what? 2.5? Yeah? I could have said it is 2.5. It is 2.5. Yeah? So you will get it correct as 2.5, but a professional mathematician would leave it as this. We mathematicians like improper fraction because it's simple, it's easy to understand, it's easy to work with. Yeah, we mathematicians generally do not like decimals. Why don't we like decimals? Because 1/3 is an exact answer. But what is a third as a decimal? That's 0.333333333, blah, blah, blah. This is not exact. So if you write a third as a decimal, 0.3, this is an approximation. This is exact. So yes, this is exact as well. This isn't much of an approximation. But I'm just going to show you why it is that in math, we prefer improper fractions. Because, you know, you could use your normal rules of fractions to work with an improper fraction. And we prefer that over decimals. You should only put a decimal in your answer if the question asks for it. So if the question says, give your answer to 2 decimal places, well, then you know decimals are expected. But in a case like this, where they are saying nothing about decimals, leave your answer as an improper fraction. Because it will be easier to work with. Because y is equal to 5 on 2x plus c. That is easier to work with than if I had y is equal to 2.5x plus c. That's not very easy to work with. Or if I had y is equal to 2.5x plus c. This might be easier than this, but it's still not as easy as this. Because at least, you know, this 2 might be able to cancel with something. But we're going to cancel here with 2.5, you know? So yes, you will get 2.5 correct, but the examiner will know that you're an amateur. Yeah, and that you're not a professional mathematician. Right? So you're kind of be giving away yourself there. Yeah, but yeah, you'll get it correct. No problem. You will get your marks for it. Other questions. That was a great question, by the way. That was a great question. All right. Another line, GH, is perpendicular to JK and passes through this point. All right. So now that I have the equation of JK, let me draw a little sketch. All right. So I don't know exactly what a 5 on 2 gradient will look like, but I know it's going to be positive, right? So a positive gradient and the y-axis cutting at 3. So this line might look a little bit something like this. Right? So what they're saying is another line, GH, is perpendicular to JK. So this is JK. J and K. Right? And passes through the point 5, -1. So the point 5 might be here, and -1 might be here. So this is the point 5, -1. And so therefore this will be my line, and it's just a sketcher, so you can't make any conclusions from it, but this will be perpendicular, right? And the gradient of the blue line JK, we just worked it out, M1, let me call it M1 because it's the first line we're dealing with. That is 5 on 2. That is the gradient of that line. So state the gradient of GH. Well, GH, we'll call that M2. And they say GH is perpendicular to JK. Right? So in order for it to be perpendicular, M1 multiplied by M2 will have to be minus 1. M1 is 5 on 2. Multiply by what will give me minus 1? Let me see earlier. 5 on 2 multiply by what gonna give me minus 1?
So negative 2 on 5.
That is all. It's just really the reciprocal. Negative 2 on 5. That way, the 2 will cancel with this 2. Right? The 5 will cancel with this 5. And this negative is what will cause the negative. And so you'll just end up with negative 1. So when you're met with this situation, just flip it and put a minus sign in front of it, and you're good to go. So we can see that the gradient of the line GH, the perpendicular line, is minus 215. Samaya, you get that?
I looked on that part. I worked out first part and I got the 5 over 2, but I saw the perpendicular thing and I figured out that I didn't do that.
But do
I understand.
you understand it now?
Yes.
It's pretty easy, right?
Yes.
Once they say the word perpendicular, this is what you should be thinking about, because this is literally the only thing we know about perpendicular lines in coordinate geometry. Determine the equation of the line GH. Well, with the line GH, we have M being negative 2 on 5. And then they said that the line GH passes through this point. So it passes through the point 5, negative 1. Well, look at that. X end up being 5. So you can tell that going to cancel with that. So we have the gradient, we have a point, so we could find the equation. Y is equal to mx plus c. And so that means that y, which is minus 1, is equal to m, which is negative 2 on 5, times x, which is 5, thank God for that, plus c. All right, so the 5 cancel with the 5, negative 1 is equal to minus 2 plus c. Throw the minus 2 across, c is equal to positive 2 minus 1, so c is equal to 1. So therefore, the equation of GH will be y is equal to negative 2 on 5x plus 1. We need to do, and this one is a drawing, graphs 1. So I'm going to just cut through this one real fast, right? Because, but the diagram below represents the graph of a straight line which passes through the point P and Q. And I could see the points P and Q there. Let me write them in one time. This is 0 on the x, 3 on the y. And this is negative 2 on the x, but 0 on the y. So these are my points PQ. State the coordinates of PQ. Yay, look, I get 2 marks there. Determine the gradient and the equation of this line. Right? So I want the gradient of the line for part 1 and the equation of the line for part 2. So let me do part 1 right here. The gradient m is equal to y2 minus y1 all over x2 minus x1. All right, let me use this as x1, y1, and we'll use this as x2, y2. Right? So y2 is 0, notice the brackets, minus y1 is 3, all over x2 is minus 2, and then minus x1, which is 0. So what will I get? I get minus 3 on the top, I get minus 2 on the underneath, So therefore the gradient is 3 on 2. The gradient of the line is 3 on 2. Part 2, the equation of the line, y is equal to mx plus c. I have m. Now I have 2 points there, so I could use one of the points to substitute x and y, and then I could find c. But I don't need to do that because I have a graph. And the graph is showing me C is where the line intersects the y-axis. So C is this 3 here. So I don't even need to do any working. Yeah, so therefore the equation of the line y is equal to m, which is 3 on 2x. And then you can see it cutting the line at positive 3. So C will be plus 3. The point 8t lies on the line segment. So this is part C now. This was part B, 1 and 2. Part C, the point negative 8t lies on the line segment. Determine the value of t. Well, that's pretty easy, right? Because I have a point here, I have a x value, and I want to find what is the corresponding y value, right? So I just put the x value in the equation, and I'll be able to get the y value. So y is equal to 3 on 2, x, which is negative 8, plus 3. So 2 into 2, 1, this will be negative 4. So therefore, y is equal to 4, negative 4 times 3 is negative 12. And then I have plus 3. So y will be equal to negative 9. 10, 11, 12, yeah. And so therefore, the point is negative 8, negative 9, where t is negative 9. Remember, they just put t here to throw you off. That's really just the y value you want to find. Zara, is it March the 5th is the line segment AB is perpendicular to PQ and passes through the point. Oh, why they come with this Strups, man. So you see what I do here? They call perpendicular, so you know we got how to get a gradient. And then they're giving me a point, so you know we got how to get the equation. Right? Determine the equation of AB. Yeah. Fine. Right? Where's the gradient of this line? The gradient of this line was 3 on 2. Right? So if M1 is 3 on 2 and M2 is unknown, right? Then the gradient of AB is perpendicular to PQ. That'll be 3 on 2 multiplied by what will give me minus 1? Not Sarah this time, somebody else. 3 on 2 multiplied by what is minus 1?
Minus 2 over 3.
Yep. Flip it and put a minus sign in front. All right, these will cancel, these will cancel. So therefore, M2 is minus 2 over 3. And now I have a point, so I'll have to do the equation thing, right? Recall y is equal to mx plus c. So, actually, I wouldn't put m. I'll put the actual gradient, minus 2 on 3, right? So this implies that y in the point here, y is 2. 2 is equal to minus 2 on 3. X is the 6. So I'll put 6 here plus c. This will be 2. So 2 times negative 2 is negative 4 plus c. I throw across that. So c is going to be 2 plus 4, which is 6. So therefore, the equation of the line AB, which is perpendicular to PQ and passes through that point, implies y is equal to negative 2 on 3x plus 6. All right, guys, we have one more question to do, so we might get out of here by 5. Anybody have any questions on this? Samaya, you see how they like to ask the perpendicular thing, eh?
Yeah.
They love it, you know. They love it. They might even sneak up and ask you about a parallel. You remember the rule for parallel, Samaya?
The equal.
Yes.
I remember the M1 and the M2 thing.
M1 will be equal to M2. All right, check in your notes, and I had it in the cheat sheet at the beginning, right? I need my graph paper for this, and this question serves as the segue into the next. Just now, draw both lines on the same paper and state the point XY where they intersect. And let me put my graph paper here, and I'm gonna just blow up my graph paper a little bit. Nice. So you had to draw both of the lines on the same graph paper and state the point where they intersect, right? So let me do this. Y is equal to x plus 1. I need 2 points, right? So when x is 0, I see that if x was 0, y would be 1. All right, cool. And if x is 5, y would be 6. All right, cool. Coolsies. Coolsies, right? Look, I have this next one. Y is equal to negative x plus 5. So if x was 0, y will be 5. Because 0 minus 0, you know? And if x was 5, then minus 5 plus 5, y would be 0. Let me draw a little sketch and see what these lines are looking like. This line is a positive gradient cutting at plus 1. So that will look something like this. This line is a negative gradient cutting at plus 5. Looking something like this. And I see that they're cutting in this region. So I don't need much of this side of the graph. And I don't need anything underneath here, really. So this sketch is showing me how to draw my axes. Yeah. So I don't really need much of this side, and I don't need much of this. I do need to see where they are intersecting. So this here is what I'm interested in. So I don't have any negatives here. So let me just keep it all positive. Yeah. Let me just be positive today, man. You know, today is a positive day, yo. So I'll draw my axes positively. This is my y-axis. So let me see. Where's the points now on this one line here is... I didn't label. I had a label. You had a label, eh? Make sure you label. And you had to put 0, 1, 2, 3, 4, 5, 6, 7. Put the same scale. Always put the same scale. 4, 5, 6, 7, 8, 9. All right. I have the point 0, 1. So 0 on the x, 1 on the y. That is this point here. And then I have the point 5 on the x, 6 on the y, That is this point here. So this is 5, 6. This is 0, 1. And let me draw that line real quick. All right. So this is the line y is equal to x plus 1. Now the next line, and I'll do this in black. I'll do it in green. 0, 5. So 0 on the x, 5 on the y. That's about here. So this is 0, 5. And then 5, 0. So 5 on the x, 0 on the y. That's about here. This is the point 5, 0. And this is my second line. And let's draw the second line. So from 5, 0 to 0, 5 is equal to negative x plus 5. Now, if we look, they want to know where do they intersect. They intersect at this point here. That is the point 2, 3. Notice that the point 2, 3 is on both of the lines. The point 2, 3 is on the blue line, and it is also on the green line. So this is the only point that is on both of the lines. That means that if I take this x and y value and I put it in here, right? Look, what is y? Right? Just let me just see. Y is equal to x plus 1 and the point 2, 3, right? There's the intersect. So if I take the 2, which is the x, and the y is 3, well, 3 is equal to 2 plus 1. So yes, the point satisfies the blue equation, right? And y is equal to negative x plus 5. Well, let me see. Negative was the x, 2 plus 5. And yes, we get 3. So the point also satisfies the green equation. It is the only point in the universe that will satisfy both the blue equation and the green equation. This is the point of intersection. So what we just did here is we had two equations, right? Y is equal to x plus 1. This is equation 1. And the second equation, y is equal to minus x plus 5. This is equation 2. And what we just did, right, by drawing the graph and finding where they intersect, what we just did was we solved the equations simultaneously. And I'm sure everybody here came across simultaneous equations before. I'm sure everybody came across simultaneous equations. Some of you all might be shaking because of it, right? But what we just did here was the graphical method of solving simultaneous equations. So when you solve equations simultaneously, what you are actually doing is you are actually solving where is the point where the two lines are meeting. That is what you're actually doing. And so this brings us to the next equations is actually a coordinate geometry topic, because what you are doing when you solve simultaneous equations is you are finding that point where the two lines are intersecting. The only thing is that you don't have to do it using graphs. So we already started simultaneous equations. This question here is actually simultaneous equations, the graphical method. So when we start simultaneous equations, I will not cover the graphical method because that's what this is. The graphical method for simultaneous equations is actually using coordinate geometry to draw your two lines and then reading off the actual solution as the intersection. So this is what I want you guys to understand. When you were solving simultaneous equations, you were actually finding the point of intersection of both lines. That is the one point that will satisfy both equations, because that point is on both of the lines.